Well, howdy, physics sleuths and inquisitive souls, and welcome to another lecture of dynamic gravity. So, excuse me, brain damage from the war. This lecture, we're going to go deep into the double slit experiments. My goal is to adequately convince you of what's going on here for all of these experiments that are showing weird results that have fueled quantum theory for like 100 years now. And it's all wrong. They don't know what it is they're measuring, they don't know what's going on. All they know is that they had this math from quantum mechanics. It works if the electron is like a cloud, which it is sometimes. And then you have classical physics, which works when the electron is not a cloud, but a point particle, which it is sometimes. And so you have these two results being muddled together, and there's so much confusion and bullshit and fuckery going on that it's really hard. You're gonna have a really hard time, my children, trying to figure out what the hell is going on here without me leading you by the hand through this rabbit hole. It's a doozy. So let's get a little liquid motivation, shall we? Because you know me. I love to be intoxicated with any drug. I love them all. Give them to me all. I love the drugs. It fuels me. It's like steroids for my brain. And I couldn't care less how that makes you feel. I don't do my drugs for you. I do them for me. And look at what they have given me. I have explored my inner space, myself, and my place in this world in a way that people can only dream of. But it's not for everyone. As the Buddha said, there's many different paths to enlightenment. Mine may not be the best for you, may not even work for you at all. It may only make it worse. But it do work for me. Alrighty. Shall we begin? So, double slit experimente. So I'm going to try and gloss over this, quickly. We're going to go into really in-depth breakdown of current theory and everything here in a minute. It's probably going to be hopefully not too long an episode, but we got to cover some things, so it's going to be what it's going to be. So double slit experiment, shooting like a light source, something through slits, and you get different results. You get a wave pattern if you don't look or measure anything to see which way the photon is actually going. And if you do measure, you just get two little splotches. Not a wave pattern, particle pattern. But this is kind of bullshit. This is what they want you to think. This is what they tell you. That way you don't start asking questions like, but what the fuck is going on? They just tell you, oh, keep it simple for the dummy. If we look, we get particle pattern, two spots, and if we don't look, we get wave pattern, many spots that are interfering with each other. This is what they tell you. They're lying to you. They're liars. You should not believe them, ever. Believe me, always me. I will never lie to you. Never. I may eat you alive if I get hungry, but I'll never fucking lie about it. The difference between me and them. I don't lie. All right? I'm going to show you what's going on here. Let's calm down. We're getting there. So, double slit experiment, first proposed by Thomas Young in 1801, as demonstrate wave behavior of visible light. In 1927, independently research demonstrate that electrons also show the same behavior. And it later has been extended to even atoms and molecules themselves. Very large quantum particles, really, that are still behaving like clouds. This should not be happening. So what's going on? Ooh, what's going on? What is it? Let's take a look. So wave-particle duality, that's the whole thing about the double-slit experiment. Is a photon a wave? Is it a particle? Blah, blah, blah. Which one is it? So here's the pattern you actually get, okay? They tell you, well, this is what you get when we do the experiment. No, this is what you actually get. You get a cluster of a bunch of freaking interference patterns if you have a single slit. Not even two slits where you're measuring one, just one slit. One slit. And the photons are going through that one slit. And you still get this interference pattern. Now, they don't call it interference pattern, but it is. Look at it. It's interfering itself. Clearly, there's dark spots and clear spots. But they say, oh, but if we have a double slit, then you have an interference pattern on top of an interference pattern. And so they just tell you. They lie to you. Well, there's no interference going on here, but there is here. Bullshit. You can clearly see, dude. Line, 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 line. That is an interference pattern, my son. And this one is the same thing. It just has more. Because it has more. It does not ever go down like this. Ever. Because if it did, then maybe the arguments on how they're proposing atoms and photons work on a quantum subatomic level might have some relevance. So this is what they tell you it looks like, even though it doesn't, it looks like this. There's a lot of bullshit and fuckery going on here, children. It's just the tip of the iceberg. It's going to get even more ridiculous from here. All right? So, we got diffraction, okay? Diffraction is the interference or bending of waves around corners, an obstacle, or through an aperture into a region of geometrical shatter, an obstacle, aperture, diffracting object, and aperture effectively becomes secondary source, propagated wave. Listen, what they're basically saying is that whenever you send light through a small hole, an aperture, a slit, whatever the hell you want to call it, you're going to have diffraction, okay? And the light, as it goes through this hole, is going to want to spread out, okay? It does not want to stay. Here's the interference pattern, which, Young says is going on, and it definitely doesn't look like that, but there is kind of a pattern going. We're going to go into that. I promise. Okay? This is a good example of, does it? Does was? Okay. This shows you how they want you to think of electrons. Just a giant freaking wave of energy, electromagnetic wave, coming at you. And then when it hits something right there, it diffracts out. So it hits a small and it goes outward. You see how it goes to this little itty bitty hole, and then it immediately goes bloop and just spaces out. This is what they're telling you. This is what diffraction is. And they have no clue what causes it. But I'm going to tell you. Because you know I'm holding. You know I'm holding the best, purest stuffest that's going to get you the highest in the whole freaking planet. You know I got it all here on my channel. And if you're new here, feel free to look at my papers I link in my description showing my work where I calculate gravity, dark matter, and dark energy with the same equation. And I get perfect results to what every single observation we've ever made. Ever. Period. Yeah, almost like I know what I'm talking about, and I'm the one. But they don't want you to know about me. Why is that? I wonder. Okay. bright spot, blah, 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 speckle patterns. This is all stupid. Single slit diffraction. Okay, so this doesn't really, this is stupid. This is not what it looks like in real life. This is just, they're trying to explain it to you as though if electrons were a wave of energy, okay? Because that's what quantum mechanics says, that they're a wave. And they do kind of act like this. And I'm going to explain this. We're going to go into this so much deeper. So much deeper. Yeah, 2 slit versus 5 slit diffraction. Look at that. Huh. More slits you add, the more diffraction you has going on. Huh. The more slits you add, the more diffraction you has going on. Huh. Interesting. I might be on the test later. Okay, so now let's go into diffraction types. There's many different types of diffraction. I tried to find them all, and I failed miserably because I suck and I'm a loser. But here's the 2 main types of diffraction. Fraunhofer diffraction. Fraunhofer diffraction. The diffraction pattern is obtained successfully by unlimited limitless distance from the diffracting system. The diffraction pattern is generally using a convex lens. When the distance about 2 points is extended, outgoing diffraction pattern waves become linear or horizontal. Interesting. And then you have fresnel diffraction, which is basically fresnel diffraction. A pattern is obtained successfully at the restricted or finite distance of the diffracting device. As an example, to consider spherical or wavefronts of the following points of the main action. Hey, what are you doing? What are you doing? Were you paying attention? Or are you looking at the lady in red? Yeah, I know which one you were doing. Go ahead, look again. See who she really is. Yeah. This is why we can't have nice things. This is why you don't figure this stuff out on your own. Your mind gets too easily distracted. Mine does too. Probably all the drugs. Okay, so we got different types of diffraction going on here. I think they're just basically saying the differences is kind of toward the setup like this one. Spherical or cylindrical, wavefronts, where this one is a plane, whatever. This is not really important information. I just want you to know there's a lot of different types of diffraction. There's more than this. There's a lot, okay? And a funny story about diffraction. When I was working at the VA as a electronics control mechanic, blah, 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 whatever, at Washington State in Tacoma. I was working out in the gym, getting my buff on, getting my muscles down, and and above there was a chain link fence, right? And it was separated by a partition of dark space with a brightly white concave space with another chain link fence that was lit up and backlit very bright lights. And as I'm looking at this, doing my reps, I see a pattern emerge of the chain link fence being cast upon the chain link fence. Now, it was completely invisible except for where the chain link fence was, but you could clearly see it. You could see the fence being cast upon it. The light was being diffracted around and then being magnified from the concave thing and then reflected back out. And it was actually impressive. I actually built a small prototype of the device, seeing if it was possible that I could use it for some sort of, telescope or magnification microscope process or something to magnify, visuals, because it magnified that chain link fence, I'd say a good 20 times. But yeah, basically, diffraction is weird. It can do all sorts of things, but you have to have a small object like a chain link fence for the light to bend around to do its thing, okay? Now, this is, there's 3 main experiments that we have to address here, children. The first is double slit experiment, where you have light going through double slits, whether measured or unmeasured, you have different patterns. Then you have what's called the delayed quantum eraser experiment, okay? And in this experiment, they radically claimed they can actually retroactively go back and violate time and go back into time and change your answer on what the original double slit experiment is going to be, depending on whether you measure a split entangled photon after it's already been cast on there, which will then tell you what it really was or it wasn't. At least so they tell you. But if there's anything you should take from me from this stupid lecture, it's that they are liars and they lie to you. They lie like they breathe, okay? This is not what it seems to be. And I am not the only person that believes this, okay? This is everybody, to show you how ridiculous this stuff is.
What I mean by that is you have to interpret that the photon is either a particle or a wave from the moment it left the light source.
Shout out, love him. He's got a great science channel.
When you decide how to measure it later, for example, if you measure it to be a wave, it must retrocausally become
we get
a wave when it was created before you decided to measure it. And the same thing applies if you measure it to be a particle.
Now,
once it's measured, that is, once its path is known, the wave collapses to become a localized wave, and that shows up as a particle distribution on a screen. But if it is not measured, that is, its path information is not known, it remains a wave and will show up as an interference pattern.
He says you get, if you do measure, he says you get this. And remember we said this is not what it looks like. But Arvin Nash ain't going to let us, think this bull is shiznits. He's going to tell us straight up what's going on.
Like a random distribution of dots. But after a while, you'll see that those dots create an interference pattern. It's as if little bits of waves were going through the slits and interfering with each other.
Yeah.
But the weirdness doesn't stop there. Such as what happens when these quantum objects interact with the measuring device. Their waves become localized. The localized wave any classical wave would. This is why we see the delayed choice quantum eraser similar to the wave any classical wave would. This is why we see an interference pattern in the aggregate of many dots. This wave-to-particle collaboration commonly shown about the double slit experiment. If you have no detectors checking the path of the particle, then you get an interference, just like I said earlier. If, however, you have a detector that measures the path, you don't really get two clear lines of photons like I illustrated.
First person knowledge on us in a long time.
You actually get a single spread out distribution.
Now he's telling us, listen, this pattern that they tell you that you're supposed to get, this double slit pattern.
Two clear lines of photons like I illustrated. You actually get a single spread out distribution of photons. What you get depends on the physical dimensions of the setup. If your slit is very wide,
the more or less you mess with this setup, the more or less you get the results you're looking for. So just know this, if you were actually switching the state of an electron or photon from waveform to particle form, depending on whether you observed it, whether you looked at it or not, then it should be an on or off deal. Like you hit a certain angle or a certain point and booyah, now it switches on. Permanently, everything is on after that. You get all particle-like photons. And if you're not at that angle, you should get a wave thing. What they were saying is true. This is how it would work. But instead, what we get is a spectrum. Meaning the closer you get to an optimal setup of this experiment, the more closer you get to the results that kind of, make your head turn like, that's kind of weird. So that right there tells you it's definitely not an on or off switch thing. It's like a thing, an interaction that is occurring more often when you have an optimal setup and less often when you don't.
You get a relatively concentrated dot on your screen because the photon just goes straight through, almost as if it didn't notice the slit at all. And this is the scenario you see in almost all illustrations, a double line pattern on the screen. But if you narrow the width of the slit to the size of nanometers, which you generally have to in this experiment because we're dealing...
I know that. You said you have to lower it to nanometers. That's true. You have to lower it, not even to a nanometer, like 0.nanometer. Maybe not point. Okay, no, maybe not 0.nanometer. No. 0.millimeter. 0.millimeter. My bad. My brain not works so good no more. Okay.
Dealing with tiny quantum things, you enhance diffraction. In other words, the photons interact more with the slits, which causes the photons to spread out as a fuzzy collection of dots.
So basically, you just say, like I said, it's on a spectrum. Closer you get to optimal, the more results you get that show your wave pattern. The further you get from optimal, and the more it just looks like classical physics because things aren't really doing the way that they're supposed to.
They don't show up as clean, narrow lines of dots. For the typical double slit illustration, it is okay to ignore this, but to understand the delayed choice quantum eraser, it's helpful to realize that what you should really see is a spread out pattern of dots, or an interference pattern if you...
See it, and there you're showing us no interference, even though there is clearly interference going on.
Don't measure which slit the photon passes through. So how does the delayed choice experiment work?
Okay.
Let me show you step by step.
So now we're going to go into the delayed choice experiment, right? So that's like the double slit experiment on steroids, where basically you have photons that go through the double slit, okay? And they do their thing like the double slit. But then as they pass through one slit or the other, before they can get back and interact like quantum physics says it does, they go through this, like, I don't know, barium crystal or something that basically... it splits the photons. If I'm not mistaken, I think it takes like a high energy short photon and converts it into two lower energy, twice as long photons. So you're basically dividing one powerful, strong photon into two weakly smaller photons. And that's basically how the quantum the quantum entanglement goes, okay? And entanglement, in case you don't know, entanglement is this, all right? I don't even remember what this was from. Whatever we did last couple weeks ago, we were getting a little crazy, weren't we? Okay. So here's the core of dynamic gravity. This is an atom, okay? And the atom consists of an electron, an up quark, which eats an electron or attaches to an electron, but it's still not as negative as the electron because the up quark is a different thing. And so it still wants more up quarks to attach to it. And so now you have three of them to get equilibrium, and they're constantly fighting over this stupid electron. Boop, 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 like at a billionth of a second, every time they do the rotation of their E field, or my bad, for a quark it would be gravity field. You want to go back and look a couple lectures about that. But, okay, so atoms have orbitals, okay? And this is just basically the equilibrium of the atom. When you get like so many neutrons and protons together and electrons, they're going to fall into the lowest energy equilibrium. And that's basically, we call it orbitals, all right? And the way it usually works is electrons will pair up, okay? So let's say we got this is one proton right here, okay? Now we're going to make another proton. Boop, beep, bop, bop. Beep, bop, bop, bop. Boop, boop, beep, beep, bop, bop. And guess what? They're going to be held by another proton. That's right. I didn't think I was going there, did you? But this is not a proton because it ate. Boop, beep, bop, bop. Boop. There we go. Okay. Because it ate this electron. Bloop. And so now it's a neutron. Okay, if a proton eats an electron, now it has two electrons in it, and that now equalizes and neutralizes all charge, and it becomes a neutron. That's a fact. We know this. This has been known for 50 years now. I'm not making this up. So let's say we have helium atom, okay? And helium atom has, say, 2 protons and 1 neutron, holding it together in the inner core. And we'll have 2 electrons. And as we learn, electrons are vortexes, okay? And we're going to get into this a lot more when I go next week into antimatter. Oh yeah, baby, we're going all out, baby. I know all. I know everything, and I'm going to share it all with you for free because that's the kind of guy I am. Okay, so they're going to want to share the same orbital because that's the same equilibrium. But they can't because they're vortexes and they're spinning the same way, so they can't add. So what has to happen is one has to flip the inertia. Bloop. So they're both going counter to balance out the momentum. So that way the atom itself has 0 momentum. Otherwise, if you have an electron that's going this way, and you have another electron going this way, the atom is going to be all out of whack and it's going to be doing crazy things. So the way nature takes care of this is says, oh, 2 electrons want to share this orbital. I'm going to invert one of the vortexes of the electron, what it is, and force it to then go the other way. And that way, once they have enough energy to overcome their initial repulsion, they now can stack neatly together. The 2 electrons can in the same orbital because they are vortexes going different directions, okay? One is going from inside out, the other is going from outside in, and they're going competing against each other. It's a thing. I explained it in my lecture on electrons. If you care, go watch. So, this is entanglement because what's happening is the 2 electrons are sharing the same space, but they can only do that if they have the exact opposite kind of spin, okay? So one's going to have a plus spin, one's going to have a minus spin, or I think for an electron it might be a plus 1/2 and a minus 1/2. I don't remember everything perfectly. But so when these 2 electrons will share the same orbital, they become quantumly entangled. One now will have up, and one will have down, left, right. It might not actually be, it might be first, but you just get the point what I'm trying to say here. This is what they are. The left spin, right spin. They're basically entangled together. They're opposites. That's what they are. Okay? Hidden variables. That's what they are. And so now when these come apart, this one go whatever, and whatever you measure this one, if it's right, then you know that this one is going to have to be left because they're opposites. They had to be opposite. They couldn't share the same place. Entangled. Photons, because photons are electrons only spaced out in time, they're not neatly wrapped up together in a vortex, they also do share the same things as electrons. But they're a little different because they're spaced out in time. So they don't have quite the same restrictions. But they also get entangled, and this is essentially what's going on. They will become counter opposites of each other. And then whenever you measure this electron or photon, you know that this one is the opposite of whatever state it was in. That's how it works. Okay? Now, blah, 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 blah,
I've simplified the illustration.
Okay. So this like barium crystal, whatever it is, entangles these photons. Now then they go and measure, okay, it goes off to the left where it then gets measured here.
Below so that you can better follow what's going on. The actual experimental setup is a little bit different, but the practical results are the same.
Straight up
we have
here.
Our double slit, but instead of putting up a screen to see an interference pattern, we put a special optical device called a barium borate crystal, which is referred to simply crystal. As a...
I was close-ish. It was in the same ballpark.
BBO crystal. It splits a single photon into a pair of entangled photons with half the energy each of the original. Okay. And this is done for every photon coming from either the left or right slit.
Now there's a problem with this, okay? The second that this photon interacts with this BBO crystal, it is now taking a measurement. It is now observing the photon, which means its wave collapses and it now goes into a point particle thing. And this is actually what happens from a perspective. This is what happens. This is not a bad way to think about it right now. I'm going to explain it better later. This is not a bad way to think about it. But what you need to know is that, as Sabine Hasselhoff says, I love her. She hates me, but I love her.
Because the photons must have known whether to interfere or not before you decided whether to erase the which way information.
Yep, right.
But this is clearly nonsense.
Yep.
Because let's rewind this explanation to the beginning.
What are you doing?
Because of this which way information, the photons on the screen can't create an interference pattern. The photons on...
Okay. So what she's saying is that as soon as these photons go through this double slit and do their double slit thing, and then they hit this BBO crystal and get entangled, now they are no longer waveform, they're not particle, which means you can no longer get an entangled, an entangled pattern. Now you're going to get a single particle pattern because you've made a measurement. Okay? So this whole delayed choice quantum eraser experiment is bullshit. There was never any wave function detected or measured. But they show you a wave pattern, and they tell you that this wave pattern matters. Yeah, we're going to get there. Okay? Let's see if we can just go straight to
the two screens showing photons from the individual slits D2 and D3, and the two screens D4 and D5, each showing half of the recombined beam, then we would see that the patterns look something like this.
Keynote: if you want to quit smoking cigarettes, get addicted to something else, like Hall's, what is this, like sore throat things? They just like overpower your throat, so you're getting like rah, and then also mix it up with like a nasal inhaler thing. Yeah, I mean, it's not as satisfying as a cigarette, but pacifies. It satisfies to a certain degree.
The quantum eraser has no effect on the original screen at D1. What's really happening is that the changing patterns are due to the scientists who are conducting this experiment, selecting subsets of the photons in D1 to show the same pattern as that of each of the other detectors.
So
how is this done?
They're choosing this detector or this detector, but when they do that, they're only choosing a subset of the entire data that they have collected. But the way that subset works out, because of this angle right here, bloop, 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 is half of it makes a pattern like this, and the other half makes a pattern like this. Well, when you combine the two, bloop, you just get a big blob, which you're supposed to see from the get-go because there is no wave function. But the way they've done it, the way they're choosing to only record one subset at a time, it divvies it up like this, and then they show you what they tell you are two separate wave function patterns, but it's all bullshit. They lie. They lie like they breathe. Why do they do that?
Recall the first thing that happens after the double slit is the creation of entangled photons. This means that there is a connection between the particles hitting the screen at D1 and the particles going down to the other detectors, where we either measure them coming from separate slits, causing no interference, or as the recombined beam where we see an interference pattern.
I mean, yeah, he's just basically telling you, man, it's just all bullshit. It's all bullshit.
Since the path information of all the photons hitting D1 is known, it is possible to single out or match.
Like when they did their thing,
this experiment implies retrocausality. And
the which path or both path information of quantum can be erased or marked by its entangled twin even after the registration of the quantum. They're lying to you. They're saying, we can change, we can go back into time and change what is it. No, dude. all they're doing is looking at a subset of the data and cherry picking the data.
The entangled
saying,
partner
"See?
photons.
It shows you what we wanted to
hitting
show
D4
you."
and D5.
Yeah, well,
we
if
can
you add
see
all
the
of it
same
together-
Yeah, we don't want to see it.
interference pattern.
Yeah, but it's
hidden
actually-
within
No, we don't want to see it.
the
This
spread
is
out pattern of D1. But we see this only because we have now
Ridiculous.
chosen a subsample
Well, you
from
can't
all
trust
the
anybody in
photons at
science
D1,
but me, kids.
which of course
They're all
is going to
idiots
be
trying to con
interfering
you.
because they are entangled partners of the corresponding photons at D4 and D5.
Blah, blah, blah.
The same thing applies to D2 and D3.
Okay.
So in the present,
So he's just basically explaining it to you. Yep, there he is right there. There's the
D4 and
detectors.
D5, you get a
Look at that.
spread out
You add them
pattern with
together,
no
just like I
interference.
said.
So what the quantum eraser is
Almost like I
doing
know what I'm
is
talking about.
creating two subsamples of the full
Don't get
non-interference
into
picture.
this, boys. Even a broken clock is right twice a day. It's just that time of the day for me. That's all. Okay. Now, this is the way they want you to think about what's going on. Okay, an electron or a photon. It's like this wave of electromagnetic energy, and when it hits anything, it all of a sudden radiates in all directions, just in a lesser intensity, and just and look at it. Oh, it's going around the corner. View again. View again. This is all bullshit. This is not what a photon is or an electron. Well, I explained this in my previous lectures. Okay, this is not right. This is what a photon looks like. This is a vortex, an electromagnetic vortex. And whenever you has an electron, it is a vortex. But when the electron makes a photon, it's making it slower than it would electron. So it doesn't have time to come back around and loop and connect. And so it's basically a vortex that's split. And now you get your photon kind of wave function going on. All right? So a photon is the same thing as an electron. They're the same thing. The only difference is one is a vortex and one is an open vortex that's just wiggling its way through, propagating as it goes. Okay? And as you can see, man, these vortexes, they can do crazy things. Like, look at this, okay? Like, he does this, and he splits it. Look at this. He compresses it, he expands it, elongates it. This is what vortex are. They're malleable. They can move around however they want. And then, if he cuts it, look at that. Bam. Now it naturally forms two vortexes because they want to form a vortex. I go into this on my lecture on quarks on why they do this, on this bio-subverte law and stuff like this. It's all cray-cray. All right? But that is electron. And that is also a photon when it's not connected, when it's coming apart, and it's coming at you long ways. Okay? It's important.
Wondered what would happen if air was shot from a giant cannon? This guy directs a vortex cannon at a house and destroys it instantly. These rings are created.
Yeah. Look at that. That's how strong vortexes are, man. They're very strong. They're very, very strong. Look at that. He knocked down a brick wall, man. Ooh. Oof. Ouch. Okay. And just so you know, whenever anything goes around, it wants to naturally form vortexes. Okay? Look at it. This is turbulence coming around, forming vortexes naturally as it comes off. That's what everything wants to form vortexes. It's like such a stable form of momentum that basically everything wants to form them. Okay? So, we've gone over a lot, but I haven't explained a whole lot yet. We're getting there, okay? There's one more thing. There's this stupid Bell's theorem experiment, okay?
What do you mean, big deal? We've told you the deal.
He showed it.
We showed you. You don't think this is a big deal, these funny numbers?
God, Richard Feynman, dude. He's such an angry, bitter old man. And I can relate. I'm an angry, bitter old man myself, so I
It's
can't.
a contribution to that deal, which is to point out mathematically that it has to happen. People knew it had to happen before.
Okay, so yeah, he's basically saying, listen.
That's the big deal. Okay, that's all the deal is. Funny numbers?
I do think
It's a big deal, these funny numbers?
Okay, so he's basically saying, listen, what's impressive about the Bell's theorem experiment is the statistical anomalies that we have that come up where statistics say it should be this, but in reality, we're getting this different number. Okay? Now, what the Bell's theorem experiment was, is they basically took photons, right? And they sent them through like polarizers, right? And they said, listen, polarized light, whatever. Yeah, break it up. If the light is not decided what it is until it hits something, and then it has to choose whether it's going to choose to be left or right, okay? And then when it goes, it's going to hit another object, and it's going to have to decide whether it's going to be left or right. And whatever this entangled photon does, it's going to have another particle in another direction that's going to always be the opposite. Okay? So, this is kind of...
Here I'm playing around with polarized light. Sunlight is unpolarized, so it doesn't really matter what angle. Use a polarizing
so he's basically
filter.
going to add like
cross,
three
then essentially light making it through
together.
one filter is...
Okay, so here's two, right? So sunlight is supposed to polarize like left, photons left and right, right? Up and down, whatever. And so if you take a polarizer and you take two polarizers and one only filters out like left polarization, one filters out right polarization, and you put them together, then what you will get is blackness. No sunlight will come through, no photons, because you filtered out the left and the right polarization ones. So there's none left to go through. You filter them all out. But a funny thing happens, and this is basically Bell's theorem experiment, what's going on.
Horizontally polarized. Then the next filter only lets through the light that's vertically polarized.
Yeah.
So cumulatively, nothing makes it through. Interesting starts to happen. And in fact, a quantum effect begins to kick in.
Now you're saying, quantum. Shut up.
If I ask three questions.
Now you take another polarizer. Now, keep in mind, there's no light coming through this, okay? There's zero light coming through this because the light has been filtered out. The left polarization, the right polarization light filtered out. They had no light.
The order, the answer I get depends on the order that I ask the questions.
If
I have a horizontally, diagonally, and then vertically polarized, I get a different answer than if I ask horizontal, horizontal, vertical.
If he takes it and he changes the filter angle of polarization so that the photons, theoretically, the Bell's theorem explains what's going on here, is the photon is not decided whether it's left or right until it hits this filter. And it has a 50-50 chance of doing this or that. And so if you have filters, you can have three, I'm going to get more than that, but you can have three where you can change the orientation of the photon 3 times and get light where normally there would be no light. And the only explanation to this conundrum that Bell's theorem postulates is that the photon has to decide what it wants to be when it hits the filter. And until that moment, it has not decided. This is not right, kids. I'm going to explain this. Okay.
Or horizontal, vertical, vertical. So in between,
but you see,
I actually get a lot more light transmission than you would expect.
With 3 filters and the right angles, the right polarization, and the right optimization, because it's a spectrum. Remember, it's not an on or off switch like they want you to believe, like, it's going to decide up or down. No, it's a spectrum depending on how much it wants to interact with at that angle. That's what it is. Okay? But
and this is an angular.
You should get zero light unless there's something going on where the electron is truly, well, not the electron, the photon is truly changing its orientation as it meanders through these filters. That is definitely happening. We can see this proof of this. But Bell's theorems and quantum mechanics interpretation of this is all bullshit. This is all bullshit. They don't know. They're dumb. Okay.
Of glass is what's called a polarizing filter, which means when a photon of light reaches the glass.
Several sets of polarized sunglasses or old photographic filters. The filter is oriented 90 degrees off from the first. What you're observing is that the
so he's just
photons with polarization that allows them to pass through a filter along one axis.
Yeah, and so here he says what a photon is. It's not what a photon looks like. Not what it looks like.
Have a much lower probability of passing through a second filter along a perpendicular axis. In principle, zero probability.
But here's where things get quantumly bizarre.
He's saying, yes, if we bring in the third, guess what?
It's brighter. This is not the middle filter generating more light. Somehow, introducing another filter actually lets more light through. With perfect filters, if you keep adding more and more in between angles, this trend actually continues. More light.
This feels super weird. But
well, they're claiming the more you do, the more you can get it to change. This is possible, depending on how the photon interacts, which I'm going to explain. Trust me, I'm going to explain. I'm going to show you everything.
It's not just weird that more light comes through. When you dig in quantitatively to exactly how much more light comes through, the numbers don't just seem too high, they seem impossibly high. And when we tug at this thread, it leads to an experiment a little more sophisticated than this sunglasses demo that forces us to question.
Yes, Bell's theorem.
Blah, blah, subtle for us to probe without deeper theories and better.
And let's say that all of these definitely.
Okay. Yeah, so this is going lots more technical babble into this whole experiment and all the conundrums that this creates and everything. Okay. It's pretty interesting.
Which means
it's pretty good stuff. Okay. Now. Let's start explaining things. My first intuition on what was going on was I tried to explain this whole thing the way quantum mechanics does, is that the particle or the photon is actually going through both slits at the same time, separating or deciding which one to go through, like a slinky, and then interacting that way. But this is definitely not the case. Okay? Explain why. Here's kind of a write-up. Young's double original experiment, sort of. This is a good explanation. They go into a lot of stuff. But, so here's a wave pattern they propose. It's all bullshit. It doesn't do that. And here's, there's an important thing here that we need to know to get to the bottom of this. Okay? And it is this right here. D. It's always about the D. So, this distance from the edge of this slit to the edge of this slit is used in calculating what you're going to expect to see quantum mechanically, how they calculate this. Sorry. Train damage from the war. I am what I am. Okay. But calculate these waves based upon this distance and the angle, theta, sine. Here's the equation. Wavelength, and you can calculate what the wavelength of light is coming through here. Beep, 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 by timesing d by sine angle theta divided by m, which m I think is peaks. I think these is like an m right here, one of these peaks, if I'm not mistaken. Let's see, what does it say? The third bright line is due to third order constructive interference, which means that m equals 3. Okay, so yeah, I'm pretty sure they're going off these peaks and whatnot. Okay. Now, it says 0.01 nanometers, and that the wavelength calculated is 633 nanometers. which means that the wavelength of the light is like thousands of times larger than the distance between these slits, okay? But that's not, this is a typo. This is bullshit. Someone was drunk when they did this, like I am when I make these. Really, as you can clearly see, dar is equal to 0.01 millimeters, okay? They misspelled here. It's actually millimeters. And if we calculate how many 633 nanometers go into millimeters, I think it's like, I don't know, 15 or 20 or something. I calculated it. Let me see. I did calculate. 15.79. 15.8. 16, let's say. So, this distance is 16 times the distance of the wavelength of the photon that they're using for this experiment. There's no way possible that this photon is going to come bloop, 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 here and then divide itself magically and go over a distance 16 times its own length. Go through here and then go back 16 times its own, length and interact with itself. This is not what's going to happen. Okay? This is why they want you to think of this bullishness as something like this. Where, oh, it's everywhere. It's infinity. It's infinite. Look at it. It goes up from every angle it hits at every corner. Blah, 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 blah. It's bullshit. That's not what it is. Okay? So, this is an important clue of what the fuck is going on here, children. It is 100% not going through both slits at the same time. It's impossible. The distance it would have to travel to do that is like tens, and some of these experiments, hundreds, maybe even thousands of times the length of the particle that you're shooting through these holes. There's no way it can do that. It's impossible. Even electrons. Okay? You might think of, well, but I like to think of photons like this because it makes me feel good. Cool, bro. But they do the same thing with electrons and atoms. What about that? It's not the same. An electron is not an omnidirectional infinite wave of energy. It's not. It's one place. It's this point particle. It's in chemistry. It's in a bond, for God's sakes. Okay? So, that is proof. We know. It's 100% not going through both slits at the same time. It can only go through one or the other. But yet, we're getting some sort of interference pattern. What's going on here? Why is this doing this? All right. Double slit observation. Yep, here we go. We have carried out Young's double slit experiment for hot electron. Hot means, I think they're moving a certain speed, like they're going kind of fast, as compared to slow or cold, meaning they're going kind of slow. They're weird. Don't ask. In a wave, in a man-made semiconductor with structures with a 25 nanometer space double slit experiment. Okay? So, this is an actual experiment. 2003, looks like it was done, November. They did this with electrons, and they're able to do this in some sort of semiconductor with wizardry and witchcraft. I don't know. Yeah. But I have no doubt that they measured what they said they measured. So, 25 nanometers is very small. Okay? Remember, this one that they used for here was 0.01 nanometers, which comes out to be like 1 million? 10,000 nanometers. So 0.01 millimeter is like 10,000 nanometers. Give or take a decimal point. Okay? So this is really, really small compared to this. Okay? And they're doing photons with this. This is electrons. Electrons. You might be asking, but Sean, how big is an electron? Well, it depends, really. If it's in its point particle form, it can be very, very small. So small that it's literally almost the size of a Planck scale. Maybe a little bigger. Very small, though. Very, very small. So small that it is almost invisible to everything. Or, when it's not interacting, then it can be in its kind of waveform, where it can be very big. How big is the wave of the electron? Well, I predicted first, like 2 years ago, that electrons and photons were the same thing because I realized that there was no photon bigger or smaller than a gamma wave. A gamma wave photon is the shortest photon you can get. And magically, the size of an electron is just one smidgen hair less than that of a gamma wave. So if you get any more energy into that gamma wave and make it any smaller, you now have an electron, energy-wise. Okay? So, I predicted this 2 years ago, and ever since I did that, ever since I came to that understanding, I have been on a tear, understanding everything with physics that no one else can explain to you. Look at all my lectures. I tell you how everything works in this world, my children. Okay? So, we have an electron. Let's say typically an electron is considered to be 0.1 nanometers, okay? Size of atom. Look at that. Size of an atom, the same size as an electron, okay? There's a reason for this. I'm going to show it to you. I'm going to show it to you. Just know this. An electron, when it's in its cloud form, is essentially about the size of a hydrogen atom. Like 0.1 nanometers, maybe even smaller. Okay? So, 0.1 nanometers. But this experiment, the divide is 25 nanometers. You might be asking, well, Sean, I kind of suck at math. Can you tell me what that number would be? Okay. 25 divided by 0.1, 250. Okay? So, this distance right here, this divide, not quite 250 because it's from here to here, but maybe 200 times. 200 times the size of an atom, or hence the largest size an electron can be. Okay? Because an electron will surround an atom in the final orbital. I'm going to explain this. Give me a minute. I promise. We're getting there. Slowly but surely we're getting there. This is a crazy rabbit hole we have to dig out. So, the size of this is 200 times of the atom or electron. Clearly, it's fucking impossible for the atom to go through both holes at the same time. But yet, quantum mechanics is saying, but it has to because the Hubble is a very okay? Now, here's a website I got put on consensus. It's basically a search, what you're looking for, and it will search a lot of different databases for papers relating, to what you're talking about. And so I was able to find all the papers I was looking for pretty quickly. Huge game changer if you're into research and you want to know if something's already been discovered. Like, I just looked up if anyone has ever had the thought in any paper that electrons are vortexes. No one. Not in the first. Ta-da! I'm the first. As always. I've already conquered all of known physics. No one was ever even close, child. It was just a race between me and myself. So, if you're into research, this is a good place to go. Now, dynamic double-slit experiment with a single atom. A single atom double-slit experiment is realized by photonizing rubidium atoms using two independent low-power lasers. The fuck kind of fuckery is this? They're like, well, yeah, we can make a rubidium atom create a wave function if we shoot it with two lasers, like one to ionize it from the 5p and 6p states, and then the other, excite, and then the other to ionize. And then when we send it through, and it has this, Coulomb's charge, I think they talk about the Coulomb's individual ionization-sided pathways can be varied, allowing dynamic control of different term, and the electron wave recedes into the Coulomb potential of the residual ion, like one of the modules used to capture dynamics. Blah, blah, blah. This is fuckery, man. They're shooting this bitch with two lasers. And they're like, look, it's following a wave pattern. Yeah, when you shoot it with the wave pattern. Funny how it does that. This rubidium atom is 100% not going through both freaking holes at the same time and then converging and creating a wave function when you look at it. It's 100% not doing that. But they're getting kind of an event. What's going on here? Okay. Maybe it's time I start explaining shit to you guys. Okay? Okay. Here is the size of a gold atom, you see, is 1/3 of a nanometer. So remember, size of a small atom or electron is 0.1 nanometer. A gold is like 3 times larger, 3 nanometers, which volume-wise from a sphere would make it like, I don't know, 9 times, really, more massful. But you think a gold would be a lot more than that. I'm a little suspicious for this number, but whatever. This is what you know. Even a gold atom, very, very far from this 25 nanometer divide, okay? This divide, this 25 nanometers. It's not going to do it, bro. It's not going to do it. Nothing is going to do it, okay? Now, there is something going on here. Here's a gold atom, okay? Let's say they were using a gold. They weren't using rubidium, but let's say they're using a gold atom, okay? I want you to look down her. We've got the orbitals, okay? Here's all the orbitals. Here's the final one, 6s. Now, if you look her, here's a list of all the electrons. And everybody said they become entangled when they share, or the diverge or spin states when they share an orbital. What they're doing. See, they got all the blocks divided up, upspin, downspin, every electron pair. Boop, 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 bop, bop, bop. But very end, in the 6s orbital, you don't have a pair, you have one. So it's not going to be sharing. And what that looks like is a giant freaking circle, a sphere, around the atom. So this electron is essentially a giant sphere encompassing the entire gold atom. So that anything that wants to interact with this gold, chemistry-wise, or whatever, is going to hit this giant 6s orbital electron. Because it's all surrounding the gold atom, just looking to interact with anything that it can. Interesting facts. You are like, Sean, but what the fuck are you talking about? Okay, let's start. Shall we begin? Okay. Okay. How do I do this? So let's say we have 2 photons. Not 2 photons. 2 electrons. a better way to look at it. Okay. We have an electron that's in its travel state. Okay. And this travel state could have two orientations. I don't know which one is right now because I'm just one man. I could use a little help. It could have one orientation where it's got boop, beep, bop, 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 a vortex with a big inner core. Or it could have an orientation where it has a vortex with a small core. Okay, and it's gonna be swirling this way, the magnetic field, and the electric field is gonna be swirling this way, right? Okay, for either or. I don't know which one is right, or if both, depending on the circumstance. I honestly can't tell you at this point in time, and it doesn't matter. They're gonna be mostly the same. It's just minute differences. It's the same. Okay. Now, and then when this electron, which could be in either of these states, when it's in its travel form, in its cloud form. Because you got to remember, as we learned, a electron is beep, bop, bop, boop, beep, bop, 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 boop, bop. It's swirling, doot, 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 like this, the magnetic field, doot, doot, giving it this, and the electric field is going this way. And as it's as it's creating these waves that are overlapping on themselves with a right-hand roll, it's making this circle, okay? It's going inside and out, bloop, bloop, bloop. And as it's doing this, you have half the electric field being generated confined inside here, inside the magnetic field. So this is a confined electric field. The other half is all going out here, okay? And it's going out like a radar wave. Boop, bop, bop. Okay? And it's going bloop, 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 bloop. Oh, man, can I do this? Yeah, it's going bloop, bloop, bloop. It's going all around, bloop, 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 as this thing is doing, and it's going to go doot, doot, doot. This is how electric fields are made. This is how I did a whole thing on this, and one's electric field, if you don't know, so I'm going over this. And what it's going to do is when it hits its inner core, when it hits itself as it's going around like this, it's going to want to blow itself out naturally till it reaches equilibrium. And that's going to give it either this state or this state, depending on how the physics work of its interfeeding into itself, which I don't know. Either or could be one the same. Same difference. Okay? So this is what it's naturally an electron is going to be. This huge cloud form of a vortex. This giant vortex. Okay? You see, look at this. See how he's got a big vortex. It's all blown out. And then you got these little vortexes shoot through it. Okay? Think of this as an electron. This is the form it's normally in when nothing is messing with it, nothing's interacting with it, and it just wants to be going along at the speed of light, blah, blah, blah. It's going to be this giant freaking cloud. But as soon as it interacts with something, as soon as it comes into contact with something, as soon as a measurement is made, as soon as an observation is made, whatever the fuck terminology they want to use, it's doing some sort of chemistry. It's reacting with something else. Okay? And now it's going to go into a smaller point form. Okay? So let's go ahead and make a very small. Beep, beep, bop, 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 beep. Boop, beep, bop, bop, boop, bop. Okay, let's say that's a small point form. It's going to be much smaller than this, but let's say this is it. Oh, you suck. Why you got to be like that? right? So it wants to be in this form naturally because as it's naturally creating its electric field, half of it's in this confined in the magnetic field in the vortex, the EM vortex. The other half is being shot out into space infinitely, omnidirectionally in all directions as it's being spun around into a directional like a radar wave goes. Like bloop, 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 and it makes a full 360 and hits everything around as it spins around. That's how the electron is doing with its electric field. It's not shooting out all at once, it's shooting out in a direction as it's regenerating itself, and it shoots it out in all directions as it makes one full rotation of the vortex. Okay? And this hits this inner core, and it blows the inner vortex out and makes it want to be a big cloud form. But when it interacts with something, okay, say we got this that it wants to interact with, okay? And this one later on, okay? This one's in front, and this one's in the back, the rear, whatever, okay? Now, let's say it wants to be like this, and it's naturally you have an electron that's going, beep, bop, 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 I'm so happy, I'm in my cloud form, and then it hits this, boom! A measurement has been made. An observation has been made. An interaction has been accumulated. Now, this electron is going to interact with this. And this is going to create force and stress pushing on this vortex, which is going to shrink it into a much smaller, more stable form. Your point form. Beep, bop, bop. So it's going to go bloop. It's going to go from this to this as it hits whatever this is. Whether this be a detector, this be your hand, this be a slit from the wall of a slit from a double slit experiment. You interact with this. It's going to go to a point form, okay? So, when the double slit experiment says, yo, broski, we get two different results, depending on whether we take a measurement, an observation, and it acts like a point particle, or whether we just leave it alone and it acts more like a cloud of electron, a wave particle, waveform particle, a big particle that's in a giant wave cloud, like quantum mechanics says. Okay? That's what's happening. It wants to be in the cloud wave-like form, but as soon as it interacts with something, that new energy, put into it, stress, whatever we're going to think about it, interaction, is going to force it into its very small point-like form. Now, if this interaction, were to happen, like let's say, why do you gotta be like this? If it were to do this, and as soon as it hit this, they'd be like, oh, I sense danger, danger, danger. And it were to shrink up into its point form, it has two options. One, it would shrink up into its point form, wherever the core is. So it'll be right here, right? Because this was right here. And so when it shrinks up, it will shrivel up unicentrically to the core. And now you have a point form electron away from the thing that interacted with it. Now, if that were the case, it would still be expected to act like a point, or like a wave to a certain extent, even though a measurement's been made. But clearly, we're seeing a different thing. So what's actually happening is this. Oh, you suck. This, when it hits this, it shrinks up and it goes like this. And it goes to its point form where its boundary is on the boundary of the object making the interaction or the observation or the measurement. Okay? Now, that's going to have an interaction between you could think of it as friction between this slit and this electron. They're interacting together. That's going to create, it's going to slow down this, whatever it's doing. It's going to create friction. So that friction, as we've seen, it's going to wrap around it. Look at this. It's going to wrap around, bloop, 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 and create patterns. This right here is showing a vortex, but is it really going to be a vortex? It's already a vortex. My point is, the more that it interacts, the more that's going to change the angle on how this thing is deflected, okay? If it didn't interact at all, it would just go straight. Bloop. Would not move its trajectory one bit or another. But because there is an interaction taking place and there is drag forces, it's not going to go straight. It's going to change. And the more it interacts and the more it gets measured, whatever you want to say, the closer it is to this wall, the more it's going to get deflected to a different degree. So it gets deflected here. Bloop. Instead of going straight, it wants to go straight, right, like this. This is the pattern if it goes straight. If it were to go straight. Beep, bop, bop. But it's not going to do that. It's going to hit this, and it's going to interact with it, and that's going to change its trajectory. And now it's going to go here. And it's going to change its orientation, too, as it's interacting, because there's drag. So let's say, it's important for the Bell's theorem. Let's say, as this bad boy is coming, it's up. Okay? This bad boy is coming, this electron. Beep, bop, bop, boop, beep, bop, 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 boop. So now it hits this, and it interacts with it. And now it turns into its point form. Okay. Bloop. And as it gets deflected, its polarization that, let's say, was completely straight up, beep, bop, bop. Now let's say it's been shifted 45 degrees. Boop. So it started as this, now it's going to end as this, because it's interacting with this, and it's shriveling up, it's shrinking it up from the stress forces, and its drag is pulling it and twisting the electron as it goes around. It's changing its orientation as it's going through space and time. This is why you can have
transmission. So has to be between
three
the asking of
different polarizations, okay? And the third one will actually make more light. Because the first one, let's say, the first one is filtering out, and it's also changing the orientation of some of the photons. The second one is filtering out the other, right? So that's going to end up blocking out the mass majority, not all, but most of the photons, because some of them are changing orientation as they hit. So beep, 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 pop, pop. It's going to be like a statistical thing, I believe, if I'm not mistaken. But let's say you have a third one. If you put it in the right spot, you're going to change the orientation of your electron. Say it's up, and say it's one filter, bloop, now it's like this. Bloop, bloop, now it hits another filter. Bloop, now it's like this. Bloop, bloop, now you hit another filter. Now it goes back like this. You see, it all depends on the filter and how it wants to interact with it. The angles of it is how it's going to interact. The angle is going to determine this. And what I'm trying to say is quantum mechanics says that the electron or the photon has not decided whether it's up or down or left or right until it hits the screen. It's not that it hasn't decided, child. It is what it is. It's up. But when it hits the screen, It changes orientation because it's interacting with it, and it's causing drag forces along the edges of the vortex where it's, interacting magnetically of EM force, the Coulomb force, whatever, doing this or that, which is going to change the orientation and of the photon and or mainly the electron, but photons are the same too. They are the same as electrons. They're just spaced out in time. So whatever an electron does, you would expect a photon to do mostly, give or take, to a certain degree. Okay? So that explains, I think, pretty good. I did a pretty good job, I think. Sorry, brain damage. The game of war. Death sucks when you lose. Price is high. Okay? So that's what's going on. So we've explained what the fuck is going on with the Bell's theorem experiment. We've explained what's going on with the double slit experiment. Whether it's a cloud form or this. And we explained what's going on with the quantum eraser experiment. Okay? I feel like we have explained everything. But because I had the brain damage and I suck, I'm going to look at my notes real quick to make sure I didn't miss anything. Blah, 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 blah. Oh, yes. Okay. And one thing to know. Okay? Okay, one thing to know. All values experiment lead to results depending on. Okay, yeah, okay. One thing to know. I want you to show this because this is an important concept. Okay? When he does this, bada! He broke the vortex. If you break an electron, because this electron is a vortex, just like this, okay? It's a vortex. But if you were to break the vortex of an electron, which takes an incredible amount of energy, because the faster a vortex is spinning with its vorticity, the more stable it is. An electron, I calculate to be going about the fine structure constant, 1 over 1/37 the speed of light. Very, 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 very fast. This is going very, very slow. This is standing still compared to the speed of a vortex of an electron. Okay? But if you break a vortex of an electron like this, remember what I said. This is an electron, okay? This is a photon. Okay? If you were to break this, then guess what? Now it goes open like this. And now what you have is an extremely highly energetic gamma wave. Okay? So, what I'm trying to say is I'm pretty damn sure these electrons are not being broken and then coming back together. Okay? Because if that were to happen, they would turn to gamma waves, and they probably wouldn't want to go back together so easily. They would just radiate energy and interact with whatever and heat it thermodynamically, whatever. So, one concept you need to know to help make sure that we're on the right track is odds are, I'm pretty damn confident when I say this, electrons don't get split ever unless they are in the core of a supermassive black hole, galactic core, which was in my episode on what's going on in the center of those things, if you're curious. Very, very weird episode. I lecture. But I think we're done here. I think we've done a good job. Wow, hour and a half. Woo! Long. I know I suck. I'm a loser, but I try. I try my best. I hope if you have any questions about this, feel free to ask. I'll do my best to answer. But I feel like I've explained everything pretty thoroughly in the last hour and a half. You shouldn't have any questions if you watch this entire lecture from start to finish. And on that note, I would like to wish you a good day. May the odds forever be in your favor. And adios, muchachos.
Like, subscribe, submit.